David Smith here with one more flipped classroom math video in the rain. 3 tips before we start. First, you can speed up or slow down the playback if that helps you digest the content. Second, you could pause the video anytime and catch up with your notes. Lastly, you could turn on the captions and watch my words go by on the bottom of the screen. Today we're going to practice using quadratic functions to solve word problems. And this lesson is just going to deal with one word problem. It's going to take you all the way through it, what we call from soup to nuts. Let's get started. So here's the problem. A rectangular mirror, so it's a mirror in the shape of a rectangle, has a perimeter of 260 centimeters. So before we get into the guts of this, I'm going to ask you, sketch a rectangle that satisfies this condition. So you're going to draw a rectangle, but I want you to put measurements on the sides so that the perimeter adds up to 260. So pause the video and do that. Okay, let's see how you did. Actually, is there one correct answer to this instruction? No, you could do this a lot of different ways. So let's say this is 100 centimeters. Oops, that would be wrong. Let's do this one. Let's say this side is 100. So I know this side also has to be 100 because the opposite sides of a rectangle are the same length. Now what does that leave for this side? Well, check it out. If the perimeter is 260, then we've used 200 here, so there's 60 left, and each side has to be the same, so that leaves 30 per side. Okay? So that sketch satisfies that condition. But we could do another one. Let's make this one a little fatter. And so maybe this is 75. So that's a total of 150. Subtract that from 260. That leaves us with 110 for both of these. So half of that is 55. So we could do 55. You could even do an insane one. This works. So one length is 1. So we have 2 centimeters used up by this really short side. Subtract that from 260, we have 258. Divide that by 2. 250 is 125, so 258 would be 129. So 129 on the side. That rectangle also satisfies the condition. Okay, now I'm going to give you that same instruction, but instead I'm going to have you use variables, because actually part of this problem involves solving for length and width in a certain situation. Okay, so now the instruction is, if the mirror's width equals x, sketch the rectangle with sides marked in terms of x. So there's your rectangle. Now this is a little bit of a harder step. It's a critical thinking step. I've taught this problem many times and students struggle a little bit with that. But what I want you to do is pause the video, figure out where you want to put your x, and then there's a way that you can label the other side in terms of x. So give that a good shot. Okay, let's see how you did. So first step, just mark x. So we're going to call that my width. Now I know also that if that's x, that has to be x. Okay? Now, real similar to when we picked a number for a side, we now know that this plus this plus this plus this is 260. Okay? So these together are 260 minus 2x. So we want to divide that in half. That's going to be 130 minus x. So this is 130 minus x. I don't need a parenthesis there. And 130 minus x. So now we've expressed the length and width of this rectangle in terms of one variable, and that's x. And so this is going to result in equations that we can use and solve for stuff because we only have one variable. Okay, next step. Find an equation for area in terms of x. So remember, area is length times width. So write an equation for area in terms of x and make that show up as a quadratic equation. Okay, let's see how you did. So area, I'm just going to use A for area. It's going to be length times width. So that's just going to be x times 130 minus x. Okay, now that doesn't quite show up as a quadratic, so let's do distributive property, and we're going to get 130x minus x squared. So that's our equation for area of this rectangle in terms of x. Okay? Now we're going to graph this. It's a quadratic function. We can graph it. So here's your instruction. Plot a graph with area on the y-axis and length x on the x-axis. Now you have two ways you can do this. You can pull out your GDC and just plot that equation and see what the graph looks like. Or you could do a hand graph. I'm going to do a hand graph in just a minute, but pause the video and make that graph. Okay, so let's talk about this graph. I did a hand graph, so I was responsible for picking the domain and the range. I had to scale my axes so that it captured a good picture of the graph. So I'm going to talk about that. If you used your graphing display calculator, you could zoom in or out on that graph just to make sure that you got the nice view of it. So here's what I did. I realized a couple things. That when width is 0, so is area. You just have this big long line, 260 centimeters long. You don't have any area. At the same time, when width is 130, area is 0 because you're using all the fence as just one side. You have nothing left for the, not fence, but one side of the mirror. As one side, there's nothing left for the other side, so you have 0 area again. Now, I happen to realize that the area is maximized when your length and width are the same, because then your rectangle is actually a square. So I put in half of my range, 65. My calculator showed 4225 as my area, and that's my max area. So I put in these 3 points, and that gave me my parabola graph. Okay? Now, knowing that, I scaled my axis to 150. That's good enough. I really only need to go to 130 for this point, 130, 0. And then, knowing this number, I scaled my y-axis up to 5,000 because I knew it had to capture 4225. So that's my graph. So now we're going to ask a few questions. First question. State the x and y intercepts. So pause the video. You can use your graph or this graph, but you should be able to state the intercepts, the x and y intercepts. Okay, let's see how you did. X, we have them right here. It crosses the x-axis at the point 0, 0 and the point 130, 0. So that's 0, 0, and then 130, 0. Now, how about the y-intercept? Where does it cross the y-axis? Well, it's crossing the y-axis at the same exact point at 0, 0. Okay, now this is a little tougher of a question. What do the intercepts represent? And what we mean by that question is, in this word problem, where we're modeling a rectangular mirror with a quadratic function, what do the intercepts represent in that scenario? Pause the video and think about that for a minute. Okay, if you said that the intercepts represent conditions of length where the area is 0, you're correct, okay? Another way to say that is that's the minimum area. So intercepts represent minimum area which is 0. Now, you might be thinking, well, that doesn't make sense. Who makes a mirror with 0 area? It's not a mirror anymore. And you're right. But theoretically, if we're talking about this rectangle that has length and width with a perimeter of 260, that's what these intercepts represent. They represent the condition or the state where you have 0 area. Okay, next question. I put that in the wrong place. So this answer goes there. Okay, so just make sure in your notes that you do that. Next one, find the axis of symmetry. Now you'll remember I gave you a little equation in the last lesson. So you might want to pause the video, flip back in your notes, and find the equation for the axis of symmetry. And then when you find that, do the plug-in step and figure out what your axis of symmetry is. Okay, let's see how you did. First off, we do need our function to do this. So f of x equals 130x minus x squared. Now I'm going to change the order of that so that it's closer to our standard general form. That's going to also be minus x squared plus 130x. Okay, axis of symmetry equation is minus b over 2a. Now this quadratic doesn't have a c, doesn't have some constant out here, or actually, more accurately, the c is 0. And that's the y-intercept, and yes, the y-intercept is at 0, so that makes sense. All right, so axis of symmetry, we're just going to plug in our b and our a in our little tiny equation there. So that's x equals, we have negative, b is 130, over 2 times a. A is 1, is negative 1, so that would be over negative 2, and this equals positive 65. Now, what does that mean? If I say axis of symmetry is x equals 65, what does that mean in terms of our graph? Okay, if you realize that that is this vertical line that goes right through the point 65, this is x equals 65, you're right. And axis of symmetry means that this parabola just reflects across this vertical line, and the reflection will map right onto itself. It's a symmetrical line for the parabola. Every parabola has one, every quadratic function has one. Okay, now here's the last question. What does the axis represent? So pause the video and think about that. Okay, if you came to the conclusion that the axis represents the width, or length, the length that maximizes area, you're right. So the axis shows area max. And it gives us the length for it. So I'm going to say width, correct length. So to summarize that point, the maximum of the graph in the context of a word problem is the maximum of this area, and it occurs on the axis of symmetry. Okay? I want to do one last little thing and then we'll be done. So I just quickly sketched a couple parabolas, but I'm showing the axis of symmetry and the vertex, axis of symmetry and the vertex. So I want you to pause the video and tell me which one of these two shows or has a maximum and which one has a minimum. And then if you've got that, what is the x value at the maximum and what is the x value at the minimum? Okay, let's see how you did. This one has a minimum. It's never going to go lower than this. The x value at the minimum is 4 and the y value at the minimum is 1. So this one has a range that's 1 or bigger. Okay? The domain for a quadratic is all real numbers, but the range is not always that. So I'm just going to say range is all x such that x is greater than or equal to 1. That would be the range, and it's real numbers. Now this one represents a maximum. The parabola never gets higher than that. The x value at the maximum is 5, and the y value is 2. So for this one, the domain is all real, and the range is all x such that x is less than or equal to 2, and it's a real number. Okay? So just a little bit of additional stuff because we did hit the maximum and minimum in the word problem. Thanks for watching. Just before you go, make sure to write down any questions that you have so that you can bring them to our next class and get them answered. Also, remember that you can watch the video again if you want to deepen your understanding. Finally, if you enjoyed the video, please click like or subscribe.